Now let's look at an example where the target is not binary. Okay, if you have binary target that is only two values, 0 and 1, then all the procedure that we discussed so far is good. Okay, so what if the target has more than two values? Okay, so here is an example in sheet 2 of the Excel file. Okay, so we have a target whether a student is going to apply to college. Okay, 0 is not apply, 1 is apply to open admission university, or 2 is apply to a competitive school. Okay, and then we have 3 predictors whether parent has at least one parent has college degree or not, 0 or 1. Okay, so gender, male or female, and then high school GPA. Okay. Now the non-binary target, okay, can be ordinal or nominal, and it makes a difference in the way in which we approach the problem. Okay, if it is ordinal, then you have a ordering, right? So that makes it a little easier to do the computation. And if it is nominal, then it's still not too complicated, but you have to go through one additional step. So let's first suppose that this is an ordinal target. Okay, so that is 0 is less than 1 and 1 is less than 2. So you can't have any other ordering, but this is the order. Okay, if that is the case, you can set up 2 different models. Okay, and then you can compute the probability of those 2 as a difference. Okay, so I'll show you how to do this. So we're going to define 2 different models. First one is target is equal to 1 if apply is 0, okay, and then 0 otherwise. So that means we have to set up a new target using this rule. Okay, so the first model is if apply is 0, right, then 1, otherwise 0. Okay. So now we have in this model a binary target. So we have converted the 3 category target into 2 category target. Okay, so now we can set up the L function. So L function is, so we're going to use these 4 cells for determining the slope and intercept values. So this is the first model. So B sub 0, okay, we need to absolute reference that because we have to copy it down the rest of the cells in the column, plus we can do a sum product of the slope coefficients B1, B sub 1, B sub 2, B sub 3, and absolute reference that with the values of the 3 predictor variables, which are these 3. So that will give us the L function, the logistic function, logit function. And then we can do exp of minus L. Okay, and then the estimated probability is 1 over 1 plus that e to the power of minus L that we have computed in column Q. Okay, so that's the probability of 1, okay, the target being 1. And then we can set up the likelihood function. Likelihood function is the estimated probability to the power of the target, actual value of the target, okay, times 1 minus probability to the power of 1 minus target. Okay. And then we compute ln of that. So we can then add these values into the maximum likelihood function. Okay. So now we copy these formulas all the way down. Okay. All right. Okay. Now we have to sum this column T to get the logarithm of maximum likelihood. So sum of that. Okay. All right, so now we can run our solver. Okay, we want to maximize the likelihood, okay, by changing these values. Okay, we don't want this to be restricted to non-negative, so that should be unchecked. So we want both positives and negatives. Okay, and solve. So we get the model. Okay, so that's our first model. Okay, where this is trained for apply equal to 0. Okay, so if you compute the probability for a new case, suppose if this is the new case, parent education 0, gender 0, GPA 3.26, then we can compute, so B sub 0 plus some product of these 3 slope coefficients with these 3 values of the new case, okay, and then we find, okay, we can copy the formula from here. Any formula will do. Okay, so that will give you the probability. So this is the probability apply equal to 0. This will give you probability apply equal to 0. Okay. All right. So now we set up a second model, but this time, okay, so in model 2, we want to code both, okay, apply of 0 and 1 as 1, and then 2 as 0. So this is going to cover 2 values of apply. So if apply is less than or equal to 1, it is 1, otherwise 0. Okay. And then we have to set up L. So now L will be, so now we're going to use model 2 now. Okay. So these are the cells where we will use solver to determine the coefficients. So B sub 0 is going to come from this cell, absolute reference stat, plus do a sum product of the slope coefficients, B sub 1, B sub 2, and B sub 3, and we have to absolute reference that, okay, and then the 3 values of the observation. Okay. Let's look at what the mistake is. C23, D23, KLM, KLM should be 9. Okay, so now the rest of the columns, these 4 columns have the exact same form as these formulas, so we can copy these formulas over, okay, and then copy this row for the rest of the rows. Now we need to sum column AA, that will give you the objective function. So here, so this will be sum of that column. Okay, so here we are, the second model. So now we go back to solver, and our new set objective is this, the second model, and the changing cells now are these from row 23. Okay, so I made a mistake here in column V. In column V, I should be checking with J9, not O9. So the original J9 is what I have to be checking for. Okay, less than or equal to 1 in J9. That's the mistake. Copy that. So now let me run the solver. Okay, so now I have solved for the second. So now if I use the second model with the same new case, so this is our new case, right? So use the second model, B sub 0 plus some product of the slope coefficients with these, okay, and then we copy that down here. So now what we get is this is the probability of apply equal to 0 or 1. Because this is an ordinal, you cannot have any other way, so 0 or 1. Okay, so now that's probability of y equal to 0. Now if you take the difference between these two, so now this one is both 0 and 1, right? Okay, or 0 or 1. So if you take that and subtract out from 0.91 that part of the probability that is 0, then you get probability of 1. Okay. So now that we have two probabilities, the third one has to be whatever is remaining from the sum, which has to be equal to 1. So if I subtract these two probabilities from 1, that will be probability of y equal to 2. Okay. So this is how you will implement an ordinal target with more than 2 values. Okay. So you can continue this process further if you have 4. Okay, you use the same logic and keep going.